Okay, now we're going to put it all together. We have learned about increasing, decreasing, and so forth, and we're going to look at this graph here, and we're going to give it a shot. So, where is it increasing? We're going to go from left to right, and I'm just going to put my pen on the graph here, and going left to right, it's increasing until right about there, which looks like at -1. So negative infinity to -1. And then it seems to be decreasing until it's like 11 maybe, where it starts to increase again all the way to 17. And then I'm going to put parentheses here. So you might think to yourself, well, what happens at 17? Like at 17, is it increasing? That is a great question. At that point, you're not really like sure, right? Like it's a mystery. Are you going up or down? So I just want you to always use parentheses for that. So I'm going to write this. Always use parentheses. Ooh, this is the part where you find out that I don't know how to spell parentheses. Always use parentheses for increasing, decreasing questions. Okay. So yeah, it looks like it's just increasing in 2 places. Let's do the next question. Where is it decreasing? Again, we're moving left to right, so it doesn't seem to be decreasing until -1. So -1, and then all the way to 11. Okay, and then, that's it. So next question, where's the relative maximum? So I would say right there at, and again, for relative maximums, we answer with x's. So that's x equals -1. And then I see a relative minimum at x equals 11. One question you might ask yourself is, why am I not thinking about this as a relative maximum? And the reason for that is the definition. So the definition says for something to be a relative maximum, then at like x equals c, then there needs to be an open interval around x equals c, but there isn't an open interval around x equals c because the function isn't defined past c. So I'm ignoring that one. That one is not a relative maximum. Okay, now absolute maximum wise, this part, gotta look really carefully. I think this part is higher. Oh, I didn't draw that well. I think this end bit is higher than this part right here. So I believe the absolute maximum happens at y equals, let's see, we're going to say y equals 24. And I'm going to put a little guess symbol because I don't know if that's exactly right, but it's close. And there is no absolute minimum because this graph keeps going down. There's no, if you gave me a number that you thought was the absolute minimum, I could come up with something even lower than that. So there's no minimum. All right, so now we're going to ask about concave up and concave down. So concave up is where the cup is pointing upward, and all of this I feel like is an upward facing cup. Another way, probably the more mathematical way to think about that, is where is the tangent line below the curve? I think that happens all in here. So I think that's from 4 to 15, 17. and then concave down. Concave down. See, all of this, all the way to roughly 4. So negative infinity to 4. So then that actually tells me what my inflection points are. Inflection is where it changes from concave up to concave down. So that happens at x equals 4. And then in terms of intercepts, let's see. So we've got an x-intercept at 5, negative 5, 5, and 15. And I'm supposed to write those as coordinate points. So that would be negative 5, 0. Ooh. Glitch. Negative 5, 0. 5, 0. And 15, 0. And I also need the y-intercept, which one is a little tricky. 2, 3, 4, 5. So I think it's going up by 2s. So we're going to go with 18? Yeah. Looks like y-intercept of 18. So that'd be 0, 18. Okay, now I want to think about asymptotes, domain, range. So to me, this looks like it's kind of going off at an angle. Well, I don't know. Let's assume that's an asymptote. I actually did not make this. I didn't make this graph, but let's assume that's an asymptote. We're going to say it's an asymptote at negative 9. Yeah. So that's a vertical asymptote at x equals, actually, is that 5, 6, 7? That's 8. Of course, that's 8. There's one right there. At x equals negative 8. Okay, and then I'll even write it as a vertical asymptote, just so I can remember. But I don't think there's a horizontal one. Pretty confident. So last question is about domain and range. So domain is all the possible x values, and since we're assuming that there's a vertical asymptote at x equals negative 8, and then there's nothing happening over here, I think that it's from negative 8 all the way until 17, because there's nothing happening after negative 17, positive 17, my bad. So I think on the x-axis, the values that are defined go from negative 8 to 17. And then I think, so actually we should look at this. So negative 8 is not defined at this vertical asymptote, but 17 is. That's a closed circle, so I want to include 17 with a hard bracket. And then last question is about range. Okay, so let's erase my really, really bad drawings. Okay, so now we're talking range. We did x values, now we're doing y values. So since this goes down all the way to negative infinity, all of these y values are accounted for. And then, this y value up here is also accounted for, which I think we decided was 24. So on the y-axis, the y values that are accounted for are negative infinity all the way to 24. Negative infinity to 24, and I want to think about if I need to include 24. It looks like we do because this is a closed circle, so that's a bracket. Cool. So I think this is the last problem. It totally is. Okay, that's section 2.1. Let me know if you have questions.